what we're going to talk about today has a lot to do with what we did in the opener here. We're going to start by talking about how we measure something, specifically how we measure something called area. If we wanted to know the area of this room, what are we trying to figure out?
How many feet are in this room?
It's not necessarily how many feet. So what do we use feet to measure? We use feet to measure how long something is, right? So in this room here, we can measure the width of the room and the length of the room, but that doesn't. Those measurements in feet don't actually tell us the area. The area of the room is what? It's how much space the room covers. Now we have to be careful here because there's a couple of different ways we can measure how much space something takes up. One of them is volume. And the volume is how much space it takes up in 3 dimensions. When I use the word dimensions, you guys know what I mean? So you guys have heard of 3D, right? 3 dimensions. So something that's 3-dimensional or 3D has a width, and it has a length, and it has a height. So it has 3 dimensions. When we're talking about area, we're not talking about 3 dimensions, but we're talking about how much space it covers, which is just a length and a width. So how many dimensions is that?
That's more than this.
Length and a width is 2, right? So when we're talking about area, we're talking about how much space something covers in 2 dimensions. So the area of this room is just how much space the floor covers. Now, we could measure the area of this room by doing what? Look at the floor. Counting the squares, right? If you look at the floor, there's a bunch of squares on the floor, right? We could figure out how much space this room covers by counting how many squares there are. Anybody know how big these squares are in the room?
1 foot by 1 foot.
They're 1 foot by 1 foot. I've said that before, haven't I? So they're 1 foot wide, 1 foot long. So they're what we call 1 square foot. So if we count how many square feet there are in the room, that's the area of the room. All right, so area is the amount of space that a 2-dimensional shape, so a shape with a width and a height, covers. All right, and we measure it by counting how many squares of a particular size it would take to cover the shape. So if we're talking about the area of this room, we might measure it using square feet. So that's the particular size, would be square feet, and we count how many squares would cover the room. So let's look at one of the problems we did in the opener here. We had this rectangle in the opener, and to find the area of this shape, which is what we were doing in the opener, we counted how many squares there were. Now, we didn't really talk about the units on these. We didn't say that each square is 1 inch by 1 inch, or 1 foot by 1 foot, or 1 mile by 1 mile. We didn't talk about the units. But basically what we're doing here is we're counting how many squares. Now, to count the squares, we didn't count each square individually, right? We came up with a shortcut so that we could figure out how many squares there were without counting each one by itself, because that would take a long time. And if I wanted to measure the area of, say, this room, I don't want to stand in here and count each square one at a time. And we're going to run into some problems, too, where some of the squares aren't whole, so we'll have to figure out how many parts we would put together. And that would get a little tricky. So we're going to start finding shortcuts here for finding areas. In the opener, we found a shortcut, but the bottom line is we counted how many squares there were, and that's the area of that rectangle. When we're doing these problems in this unit, this triad, we're not going to use units. We're not going to use things like inches and feet and miles. And actually for area, we're not going to use inches, but we would use what? For area, it's an inch is a length. How do we measure area? Well, it's length times width, so what's inches times inches? Or feet times feet? Square feet. Remember, anything times itself, we can use exponents, so it would be like inches squared, or square inches, or feet squared. We're not going to be using those units, but when we're doing area, just kind of think in the back of your head, when you move into geometry class next year, you're going to be using units along with these areas. For our purposes, for doing the algebra with this, we don't need to worry about the units. All right, so the next thing we're going to talk about is rectangles. We're going to be talking specifically about how we find the area of rectangles. And we already did this in the opener, but before we get into the formula we're going to use, what is a rectangle? It is a shape. All right, so is this a rectangle? Well, it's a shape, right? But it's not a rectangle. So What makes a shape a rectangle? Let's just kind of start throwing things out here until we get a rectangle up here. Okay, it has four sides. So here's something that has four sides. Is that a rectangle? No, what's wrong with that? Okay, the sides aren't straight. So let me make the sides straight. So it's going to have four straight sides. 1, 2, 3, and 4. Is that a rectangle? No? Okay, it needs to be closed in. So it's got to have four straight sides that completely enclose the shape. Is that a rectangle? No? Are we getting closer though? No. Yeah. No? We're not close? No. We're getting closer, I think. All right. It's not a rhombus, but it's not a rectangle either. It's what we would call a quadrilateral. It's just a four-sided polygon. What else needs to be true about this? Okay, the sides are parallel. So we might have two sides that look like this. And, all right, so this is actually, whether or not it looks like it, this is closer to a rectangle. It's not quite right, though. What else needs to be right? So let me give you a little bit of guidance here. So we've got four sides, which also makes it have four angles, right? You guys see the four angles? Mm-hmm. So there's something that has to be true about those angles to make this a rectangle. They have to be 90-degree angles. So there's a few different ways we could call it. They're 90-degree angles, or right angles would be another name for it. Have you guys seen this symbol before? A little box in the corner like that. That means that it's a right angle. What does that mean for it to be a right angle? It's a 90-degree angle. So it's kind of hard to describe, but like if you look at a piece of paper, the corner of your desk or the corner of the room, or you look at the squares on the floor, the squares in the ceiling tile, they all make 90-degree angles. And the key is, when these lines meet, I'm going to kind of redraw this a little bit here. When these lines meet, all four angles that it makes are all the same. And there's another name for that too. It's called perpendicular lines. So when two lines are perpendicular, they make right angles. All right, so the corners of a rectangle have to make right angles. All right, that's the last of the things that need to be true to make this a rectangle. So if I finish this here, we get something that looks like this, where we have four straight sides that enclose a shape with four right angles. So Kiera just made a good point that if you have a square, it's also a rectangle because it has four sides that enclose a shape and it has four right angles. So a square is a special kind of rectangle where all four sides are also the same length as each other. Where a rectangle, that doesn't have to be true. You'll notice in this rectangle I drew here, this width right here is longer than the height right here. All right, so in a rectangle, they don't have to be the same length, but in a square, they do. All right, so a rectangle is a shape that has four sides and four angles, and those angles are right angles. So what I want you to do is write that definition down and draw a picture of a rectangle that has those four sides that enclose the shape with the four right angles. One other thing I want to point out about this rectangle that's going to be kind of useful for us later, if we know how high or how tall a rectangle is on one side, let's say I know this is 3 inches or 3 miles or whatever the units are here. Let's say I know this side is 3. What other side is going to be 3?
The other side.
Yeah, the right side. So if the left side is 3, then I know the right side also has to be 3. So whatever the height is on one side, the height is how tall it is, then it's going to be the same over here. And the same thing is true for the width. If it's one width across the top, it's the same width across the bottom. That's going to be something that's going to be useful in some of the problems we're going to do later. We don't really need to know that, though, for this, though. What we're going to do now is we're going to find the area of rectangles. And we actually did this already in the opener. So let's just refresh real quick. You don't need to write this down yet. But let's say I have a rectangle that looks like this, and it's 2 units tall. It doesn't really matter what the units are. It could be 2 inches tall or it could be 2 miles tall. And it's 3 units wide. To find the area, remember we find area just by counting squares. So this is 1, 2, 3, 4, 5, 6. All right, now that's one way to do it. That's actually what we wrote down for the definition of area. But there's a shortcut. How can we do that another way? Yeah, we could just multiply since we have two rows that have, well, I'm sorry, 2 rows and 3 columns, so 2 rows of 3 squares each. We can just multiply 2 times 3. We can multiply the height times the width. So the area of this rectangle here would be 2 times 3, which is 6, and that saves us from having to count each rectangle individually. And it also helps us with something like this, where if we have a rectangle where we don't know the height and the width, but we have variables in there, like h and w, we can find the area of that by doing what?
H times W.
H times w, height times width. All right, so on your notes, I want you to label the rectangle where it says, how do you find the area of a rectangle? Label that rectangle with the height and the width. And then the area formula is going to be this right here. A equals H times W. Now, for our class, for our purposes, I'm always going to do height first and width second. But does it really matter if I do H times W or W times H?
Either way, it's going to come out the same.
Yeah, we get the same answer either way. I'm always going to do height times width so that it's consistent, and that's going to help us with some stuff later. But we get the same answer either way. I'm going to say this one more time. If this were a geometry class, we would include units. So if this was, say, 2 inches by 3 inches, then our units would be 6 square inches, because inches times inches is square inches. Or if it was 2 miles by 3 miles, then it would be 6 square miles. We don't need to do that here, because we're going to use this for doing some algebra problems later on this triad, and for the algebra problems, the units don't really matter. All right, so when you get into geometry next year, just keep in mind there will be units on this also, but you don't need to do that here. All right, so let's do a couple examples. Example 1, we just want to find the area of this. Go ahead and try this on your own and make sure that you show any appropriate work for this. All right, so to find the area, we're going to use that area formula. You have it written on your paper. I'll write it up here real quick. So it's height times width. So just like we did when we were finding slope, or just like we did when we were finding percent change, anytime we're finding the answer to something, in this case area, we want to show what we're finding. So we're going to write A equals to show that we're finding area. Be sure that you do that. And then we're going to multiply the height times the width. Again, the way I'm always going to do it is height first and width second, but it doesn't really matter if you have yours flipped. All right, so what is the height of this rectangle? 8. What is the width of this rectangle? All right, so the area is going to be 8 times 9. You need to make sure you show that to show how you're getting your answer, and then you're going to get your answer. 8 times 9 is 72. Since we have some work here along with our answer, we need to make sure we box our final answer. Next example. This one's a little different because we only know one of the dimensions and we don't know the other one. The other one's a variable, but we can still use the area formula just like we did on the last one. So using the formula on this one, we get area is equal to height. What's the height? 8 times the width. What's the width? X. So we get 8 times x. And what is 8 times x? 8x. It's just 8x. I'm going to put it as a separate one here because we don't need the multiplication dot in there. You don't necessarily need to do that, but that's it. So we don't know what the width is. So the area of this rectangle depends on x. So x is going to be in the area. If we were to plug a number like, say, 2 in here, say x is 2, then what could I do with this to figure out what the area is? We could just plug 2 in for x, right? So we would have 8 and then a 2 where the x is, so the area is 82, right? Yeah, that 8 next to the x means 8 times x, right? So it should be 8 times 2, which is 16. So if x is 2, then the area would be 16 by putting the 2 in there for x, not 82. Let's talk about that 2 real quick. We don't know what x is, so I said maybe x could be 2. According to the picture, why might 2 not seem like a good number? Tyler? Yeah, if you look at the length of this side, this is 8 here, and this side looks like it's longer than the 8. It actually looks like it's about twice as long as the 8. So we would guess that x is probably closer to 16, according to the picture. One thing I want to warn you right now is the pictures we're going to give you are not drawn to scale. Meaning that even though this side is longer than this side right here, that doesn't mean this couldn't be 2. All right, the pictures are not drawn to scale. The important thing is that we know how to find the area based on the numbers and the variables that are given to us, but the sizes might not necessarily be right. All right, so that could be 2, even though it's bigger than the 8. Moving on. This is example 3. All right, so using the area formula on this one, we get A equals height. What is the height of this rectangle? 3x times the width, which is 4x. And the most common answer that we see on this one, 3 times 4 gives us 12, so that gives us 12x. What do you guys think about that? Is that what you guys got? No. There's a problem with that. And just to show what the problem is, or show that there is a problem, I'm going to just put a number in here. I'm going to use the same thing I used on the last one. Let's say x is 2. All right, so if x is 2, then we can figure out exactly how big these are, right? So if x is 2, what is 4x? What's the width?
8.
That's going to be 8, right? And what is the height? 3 times 2 is 6. So when x is 2, the area should be 6 times 8, which is 48. All right, but with the area formula down here, when we said x is 2, if we put 2 in for x, what's 12 times 2? So we got 48 one way and 24 another way. That's a problem, isn't it? So the area should be 48 if x is 2. But if we say the area is 12x, we only get 24. So there's a problem with it. Who can tell me what the problem is with this 12x here? So if we look at what we're doing here, we did 3 times 4 gives us 12, but x times x is not x. If we say x times x is x, that's like saying 5 times 5 is 5. 5 times 5 isn't 5, is it? No. Or 9 times 9 is 9. That's not true. So when we multiply something by itself, we can use exponents, and instead of saying x, it's going to be x to the second power, or x squared. All right, so instead of 12x, it should be 12x squared, because we had an x times an x. So anytime we multiply a variable by itself, then that variable is squared. Just like when we were talking about units, if we had inches times inches, we got inches squared. So inches times inches are inches squared. X times x is x squared. Y times y is y squared. C times c is c squared. 5 times 5 is 5 squared, which we can figure that out because it's a number. We know that's 25. All right, there's 4 more examples for you. In fact, they're on the back of your paper already. You don't even have to write anything down. Except you need to show your work and show me how you find the area of each of them. I'm going to warn you right now, example 6 and example 7, you're going to have to find the area of individual rectangles, 2 separate ones in this case, in example 6, and then add them together. All right, it says it up here in the directions. You want to add those areas together. In example 4, to find the area, don't forget when you're finding an area, write A equals, since we're finding an area. And it's going to be the height, which is 4 times the width, which is 9. 4 times 9 is 36. All right, so we're going to box the 36. By the way, when you do something like this, you should only box the 36. Don't box the whole thing, because then you're boxing your work along with your final answer, and that kind of defeats the purpose of it. So just box your final answer on those. This next one here, we have A equals, what's the height? What's the width? What's 2x times 3? 6x. So we multiply 2 times 3 to get 6, and then we have that x on there. We don't have another x to multiply it by, so it's just an x, not an x squared. So we get 6x for that. All right, so again, if we knew what x was, if somebody told you x is 7, you could put 7 in there, and that would give you the area. All right, now, on these here, what we're going to do is we're going to use a property of area, which is called the additive property, meaning that we can find 2 separate areas, find the area of this one right here, and then find the area of this one right here, and add those together to get the area of the whole thing. All right, so let's just do these one at a time. And what I'm going to do is I'm going to find the area of each of the small regions just by writing it inside of the boxes. All right, let me use a different color so you can see a little better here. So the area of this one is going to be what? What's the height? What's the height? Okay, times the width, which is 2x. And 3 times 2x is 6x. Now this isn't my final answer, but I am going to use this to get my final answer, so I'm going to circle it just so I remember to come back and use that part of it. Alright, then moving over to the other rectangle. Finding the area of this rectangle, we're going to do the same thing. What's the height of this rectangle? 3. Why is it 3?
I can't see that.
Yeah, so the height of the rectangle here is 3. And it's going to be the same all the way across. So the height here is 3 and the height here is 3. That's one of the things we talked about with the rectangle, is the height is the same all the way across. So the height is going to be 3. And what's the width? 4. And so the area of that rectangle is going to be 3 times 4, which is 12. All right, now how about the area of the whole thing? How do I find the area of this entire region then? Not going to multiply. Remember I said the areas are additive, which means that we're going to add them together. All right, so we're going to take each of those areas and we're going to add them together. So the total area is going to be 6x plus 12, which is what?
18.
I knew you guys would say that. It's not 18x. Why can't I add those together? They're not like terms. Since they're not like terms, this is your answer right here. All right, so I want you to go ahead and try example 7 just like I did there. So find the area of each of these rectangles inside of those boxes and then add up all 4 of those areas to get your total area. Let's find the area of each one of these rectangles individually, and then again we're going to add them together to get the area of the whole big rectangle together. So in the first one, the top left one, what is the height of this rectangle? 2x. And what is the width? 3x. So that gives us an area of 6x squared. That square is important there because we do 2 times 3 to get the 6, but when we do x times x is x squared. So it's important that we have that square on there. All right, so I'm going to circle that. Again, I'm circling it, not boxing it, because that's not my final answer. I'm going to use that later to get my final answer. Let's move over to this one here. What is the height of this rectangle? 2x. What is the width of the rectangle? 7. And 2x times 7 gives us an area of 14x. Okay? Let's move down to this one. The area is the height, which is 5, times the width, which is 3x. And that gives us an area of 15x. All right, and then the last one, the area is the height. What is the height of this rectangle? 5. So remember, the height here is the same as the height was over here. So this 5 is the height all the way across, here and everywhere in between. So the height is 5, and the width is 7. So we get an area of 35. All right, so to find the total area, we're going to add all of those together. And I'm just going to go in the order that we found those. So the area is equal to 6x squared from the top left one, plus 14x from the top right one, plus 15x from the bottom left one, plus 35 from the bottom right one. Now there's one more thing that we want to do before we box our answer here. What's that? Yeah, we can combine some like terms here. Now you need to be careful. Is the 6x squared a like term with the 14x and the 15x? No. When we have an x squared, it is not a like term with the x's, so we can't combine that, but we can combine the 14x and the 15x. Another thing we're going to do, and we'll talk about this, kind of like what we did when we were solving equations and simplifying expressions before, the order that we write this is important. So we're going to write the one with the biggest exponent first, which is the 6x squared. Then we're going to write the next exponent, which is going to be x to the first power, even though there's not a 1 on these x's. That 14x and the 15x are to the first power. So what's 14x plus 15x?
29x.
Plus 29x. And then we'll just bring down our plus 35. And that right there is the area of the entire thing. So I don't need the a in my answer here because this equal sign means that it's equal to the line above it, and this expression right here is equal to a. So following those equal signs, I know that this is the area of the whole thing.